Okay, so let's take a look at some thermochem once again. So understanding heats of formations and Hess's law, long and short. So when we're looking at our first question here, which is asking us about an endothermic reaction. So I'm just trying to get this pen to show up. If I can have some luck here. Nope. Not that. Here we go, one more time. There we go. Okay. So when we're looking at something that is endothermic, it is going to absorb energy, so making your surroundings colder. When you're looking at the first part saying combustion of methane, this is actually a reaction, and we know combustion will give off heat. So we know this one is exothermic, and we don't look at our data booklet for that because it's not an enthalpy of formation. Now, all of these ones about formation from elements, now you can look at page 4 or 5 of your data booklet, if your data booklet is from the Alberta curriculum, and then you're just looking at whether you're endo or exo. So carbon dioxide has a negative value, so that would be exo. Formation of acetylene, that has a positive value, so that should be our answer, but let's just double check with the formation of ethane, and that one, taking a look, is also negative, so that would be exo. So your answer for this one is C. So when you're looking at page 4 or 5 for delta H of the whole reaction, as long as it's a formation reaction from elements, so by itself, then you can use page 4 or 5. If it's asking about a reaction, like the combustion of methane, then you have to do a little bit more. So with this one, the molar enthalpy for the combustion of methane, here we can't just look at our data booklet because we know our data booklet is just formation. So here we have to write out the reaction and use Hess's law short. So when I use Hess's law short, I like to just use a very short form formula, which makes sense to me, and that's the delta H of the reaction is products minus reactants. So to do this, we need a balanced chemical equation. So you have CH4, we're going to add in oxygen because it's combustion, and your products will always be carbon dioxide and water. Now, if you take a look at page 4 or 5 of your data booklet, water exists in more than one state, and we're going to use the gas state here, and that's because the question doesn't give us any indication that it's a closed system. So if it doesn't tell you, you could assume it's an open system. Now, before we fill in any other values, we have to balance. So we'll put a 2 here, and I believe we just need a 2 here. And then we're all balanced. Now you can use Hess's law short and start filling in some values. So the value of methane for formation is negative 74.6. The value for oxygen, you won't find it because you don't need to form oxygen, it exists. So any element alone has an enthalpy of 0, and we can still multiply it by 2 and show nothing's going to happen. Now on the product side, you have carbon dioxide, so negative 393.5, and you have 2 moles of water, so times your value of by 2 of 241.8. Okay. So when we're filling these values in, each of those values are kilojoules per mole. Because you're multiplying by how many moles you have, you just have kilojoules the whole way through. So if I want delta H of my reaction, I'll get my total for my product side. So in my calculator, I'll do negative 393.5 plus 2 times negative 241.8, giving me a total of negative 877.1. And I'm going to subtract my reactants, so negative 74.6. When I do this, I'll get negative 802.5 kilojoules, and that's for the reaction. But because it's asking for the molar enthalpy of methane, then you divide by the amount of moles that we have of methane, and in this case it's just 1. So divide it by 1 mole, it's not going to change your value. If it was anything other than 1, it would. So your answer here is C. Now your last one is a little bit longer, and this is where you have a target equation and then a series of equations that you can manipulate. So when we're doing this, the 2 rules you have to remember is if you need to flip one of your manipulating equations, you change the sign on delta H. The other rule is if you multiply or divide your equation by any number, then you multiply and divide your delta H as well. So when I start questions like this, I begin with placement. So I see CH4 as a reactant. I see it as a reactant. I see it as a product. So I do want to flip this reaction because I need it as a reactant. So let's flip this one. And because I'm just doing this quickly, I'm not writing in my states unless it's to deal with water. But if I was to be a little bit more accurate, I would be writing in my states as well and just showing all the work. I also usually keep the gases for last. So I'm going to move on to the next one, which is CCl4. I see it as a product in my target. I see it as a product in my manipulating equations. So I'm just going to write this one down again. 2CCl4, and because I'm keeping it the same, I don't do anything to my delta H. Now my last one, I see HCl as a reactant, oh my gosh, as a product, and it's a product here, but here it has 2 moles, up here it has 4. So to make that 4, I'm going to multiply this whole equation by 2. So let's write that down. And if I'm multiplying by 2, your delta H also has to be multiplied by 2. Okay, so now if I go to add my equations together, I could see things canceling. So I see carbon as a reactant and as a product, so those will cancel. I see 2 hydrogen gas molecules on each side, so that will cancel. And now when I go to add my reactants together, I have CH4, and then I have 2 Cl2 in the second reaction and 2 in the third. So when I add them together, that will be a total of 4. And on my last part here, I don't know why I have a 2 here because there's not a 2 up here. I have CCl4 and 4HCl. So now my last step is to add all my delta H's together. So let's do that. And I'll see that I get B as my answer. So with Hess's law long, also called Hess's law mathematical, just take a look at your target. Start by making sure you have those bigger molecules where you need them, whether it's a product or reactant, and then look at your moles so we know if we have to multiply or divide. If this helped you, please like and follow. Hope you have a great day, and if you have anything else you would like me to show, please just let me know and leave me a comment. Thanks.